Aloha, Rich Halverson here. Oh, wait a minute. There I am. Aloha, Rich Halverson here. This is ITS388J, and today I'm going to go over Chapter 3. So let me share my screen. Let's see, here it is. Share screen 2. All right, so even though it's 1 week later, I'm going to go over branches, because branches is when we first get introduced to the syntax of Java as it's different from Python. So let's open up the textbook. I guess I can click over here. And we're in chapter 3. So let's see, I got on my, these are the sections that have challenges. And so I'm going to try to buzz through at least one of those for each one today. And I see that about half of you, a little bit more than half of you have done them already. Very good. You could have more than half of you could have been partially through these, but very good. Let's I can put this over someplace else now. And let's start with yeah. Okay, let me just real quick close this. All right. Okay, so let's start with branches, and you know, these are if statements, and you know, in Python there's like if, and then you can have elif for else, if, and then you can have an else. In Python it's similar. Let's see. This explains if. Well, you understand if. Is there a This explains if. You understand that completely. Just click through these, maybe you've done the Python ones already, so you understand how if works. It just, you know, you use a conditional, then you branch out. This is a if else example, and it says, you know, you can go either, if it's true you go one, you do certain code. If it's not true, you do a different code, and there's no, you know, it's either one or the other. And then you can have something that looks like this, where you have successive if, else if, else if. And here we see this is what the keyword is in Python it's elif, and in Java it's else if. Excuse me. Oh, it's else if with a space. Excuse me. All right, so here's all right, these are easy. Let's just real quick here. Okay, the program's output is oh, okay, what's the output? We start, and the variables numapples equals this. And then if this is true, am I supposed to put something here? No, that doesn't work. Okay. All right, first this executes. Where do I read? All right, I'm going to put A here because it's definitely A. Then I'm going to put K. Let's see what it does. Oh, okay. It's weird that that's there. What's the next one look like? I guess maybe this is the initialization. Gets set to 5. If it's greater than 3, put a B. Yeah, it is greater than 3, so let's put a B. And then we put a G. And that's all. Worked very good. Okay, that's easy. What's the next one? Detecting if two items are equal using using an if. Okay, so this is okay, here now, what you're learning is not how an if statement works, because you already know that. This is the syntax. And so oops, what did I just do? The syntax is, okay, we use double equal sign for equality, that's the same, but we need to enclose the indented part, which would be in Python. We need to enclose it within the curly braces. Okay, now in Java, the indentation doesn't do anything. The compiler ignores the indentation. White space is white space. In Python, indentation means something. In Java, it's the curly braces that mean something. You enclose the block in curly braces. They can be all in one line if you want to. And but in Python, it's got to have that indentation. So in Java, you can put the entire program on one line if you want to, with no line feeds, no returns. But it's hard to read. It would be hard to read for the human. But in Python, you cannot do that. Python requires line feeds and indentations. So anyway, so everything else is the same. You have to put the if thing in parentheses. All right, everything else is the same. I'm going to go pretty quickly here because I want to get to the. I want to try to get. I guess there's only one lab at the end. All right, so this tests your understanding of the if else. This is not equal, just like Python. You do these. Type the programs. Okay, so this is the program here. And so here we said num puppies. So I'll just do it. First we said num puppies equal to 4. Then if num puppies, that's not true. It's going to print F, and it's going to print that new line, and then it's going to print H, and then the new line. So is that correct? Yes. How about this one? Let's start it. Okay. Oh, we're supposed to put coding. All right, that means we have to read it. Write an if else for the following: if the ticket users. I'm going to be really super lazy here. Copy, and I'm going to put it right here. If user tickets is not equal to 8, execute. No, we don't need the word execute. Award points equals 10. We have to put the semicolon there, and then we have to delete that period and close the if curly brace, and else. This should just be else. This award points equals number of tickets. Close parentheses. Oh, gotta put the semicolon and then close the curly braces. And we don't need to put a semicolon after the curly brace. Well, I don't know. It's pretty sure at least the other. Let me just check this. Oh, what? It's possible that it's because this is an uppercase I. User tickets are not equal to 8. If that, then that, then that. Yeah, it's probably because. Award points is defined. Oh, wait, I'm not. Oh, user tickets is that. Award points is that. Otherwise, award points is user tickets. Okay, is this correct now? All right, that's the correct answer. So it was because I had a capital I instead of a lowercase I for the if. All right, very good. Okay, so make sure you go through all those. Detecting ranges with branches. Okay, so this is how you, this is an example here. If you want to, the range is less than 6, age less than 6, and then between 6 and 8, and then between 8 and 10, and then between 10 and 12. And so the way you write that up is you have to first take care of everything below 6. That's this one. And so if it's below 6, that goes in here. And then if it's greater than 6, but less than 8, then that goes in here. And if it's greater than 8, but less than 10, then it goes in here. And if it's greater than 10, but less than 12, it goes in between there. And then at the end, it's everything else. So that would be equal to 12 and older. So, but anyway, this is how you write it. Standard, we have to do these kinds of things all the time. You have to write code like this all the time. This tests your understanding of that. And remember, okay, this is, well, you can figure this out. Pay attention if it's less than or greater than. And so what range is this? Are we just supposed to draw the ranges? Okay, so if it's less than 10, it's okay, and then less than, yeah, this one is there. Okay, anyway, you can do that one. Okay, here's a challenge. Indicate the range, let's start it up. Indicate the range covered by the following decision. If it's less than 20, then if it's less than 20, go here. So 0, non-negative integer. Okay, so I guess we got to start with, I'm just gonna go this, and 20, 19. So between 0 and 19 goes here. Yeah, is that it? Yeah, right. Okay, so you can do the rest. Okay, what's this one? Let's start it up. Type the range for the given branch. For y equals 1, see, assume x is a non-negative integer. Range for y equals 1 is, what is x? Okay, what is x for when y ends up equaling 1? Well, it's got to be less than 7. So is this some sort of non-negative? So it's going to be between 0 and 6. Okay. When y is equal to 1, then it means that this was executed. And what does it take for this to be executed? It's be 7. X has got to be less than 7. Yes, this is right. Let's see. I probably don't understand the question. Oh yeah, there it is. Let me do the third one. Oh, big deal. 3. Well, that would be, it's going to be 26 to 34. 26 to 34. Is that right? Oh yeah, very good. Okay, what's next? 3, 4. All right, so what we're learning with detecting ranges of branches. Okay, so relational operators. Okay, so you understand that we have to use. Okay, you understand these because we have to do the same, exactly the same thing in Python. What is this? Using the sequential nature of multi-branch if then else's insurance prices. Okay, oh look here, it's doing us insurance prices. This is an if else if it's else, you know, whatever. So if you are if your age is less than 18, less than 16, it does this. If your age is 16 to 24, 20, or if it's 25 to 40, 39, and so on. So that's what you can see that there. So that's right, you don't have to click through. Other classes have to click through. All right, type the program's output, start. Eggs is less than or equal to 5, so I'm going to print a B with an enter, and then an H. So that's okay, that's easy. Oh, got some code here. All right. Write an expression that will cause the following code to print less than 20 if the value of user age is less than 20. If the value of user age is less than 20, I'm so lazy. If oh, I gotta hit start first. If paste, I don't know. I'm supposed to write my code here, right? And I look like it. Okay, good. Okay, if user age is less than 20. That's what I say. All right, so you can do the rest. What's this one? Relational expressions. Write an expression that will cause the following code to print $ or more if the value of num cents is greater than or equal to 100. So somewhere we got to have this. Somewhere I got to put this. Okay, just spitballing here. And so that would be here, I bet. So I'm going to delete. Oh, I got to press start. I'm going to delete this. Oh, this is just too easy. Wasting your time, I know. Num sense is greater than or equal to 100. Greater than or equal to 100. I'll put some spaces there. And so I bet you this is it. Wait a second, is that right? Oh, yeah, I think. Very good. All right, what's this one? Detecting ranges using Brent. Okay, so we're going to read in a number. And so we read in 8. This is equal to 8. If 8 is less than 10, it is. So print a G. All right, here's a G. Print line. And then no, that's it. I'm sorry, let's do the hardest one. These are just too easy. All right. We're going to read in 27. Is this true? No. Is this true? No. Is this true? Ah, yes, this is true. So we're going to print a V. V with return. All right, is that it? All right, if these are that easy, I'm gonna let's see, write an if-else statement with multiple branches. Oh, this looks a little bit harder. Something like multiple if else with multiple branches. Okay. If something, then and that, else if something, then's that, and then ending. So that's what it's got to be. It's structured like that. And we've got this one. Oh, we're going to be printing distant future. Let's see, I got a copy of the print line thing, this thing. Sorry. Just don't want to make a mistake, usually. So this is going to be something like this. And so so is this. I'm just going to copy this, put it here. There we go. And so we need a 1, 2, 3, 4. Okay, so there's got to be 4 of those. We only have 1, 2, 3, and then we need an else. So this just needs to be else. I don't need to have this part. And one of them is distant future without quotes. One of them is this one. All right, so they have to be like in the same order. I have to be increasing or decreasing, I think. So first of all, I'm just going to put this here. Let's see if this works. I'm going to put that there, and I'm going to put 21st century here. And I'm going to put 20th century here. And I'm going to put long ago here, when both of my grandparents were born in long ago. So if given year, oh, I can just do this. Excuse me. If given year is 20, just a second. Given year is 2101 or greater, is greater than or equal to 2101. My daughter will live that long. And then it's else if given year is okay, so now it's we know it's less than 2101, but we want to know, but it has to be greater than or equal to 2001. And then it's got to be, so if it gets to be down here, that means we're talking about something less than 2001, but greater than 1901. 19. Otherwise, it's long ago. Let's see if that's right. I wonder if it's my computer, or they have to send something back to a server to get a result. Well, anyway, I got it right. Okay, what's next? Detecting ranges using logical operators. Okay, so here you can just combine stuff, and you maybe would do that if more than one distinct range you were supposed to do the same thing with more than one distinct range that, you know, didn't overlap. And so then you can use these logical operators. Yeah, you know this is same as Python, exactly the same as Python. And oh, the ampersand this is and. In Python it's AND, and there's or is two vertical bars in Java, two vertical bars. That's all. And it does just like in Python. If it's doing an and it comes along and it evaluates the first one and it ends up being false, it's not going to bother evaluating the second one because we already know it's false. So it just does this already. And you got to remember that when you're doing something like doing an automatic plus after a variable is used. So anyway, is that in Python? Yeah, that's in Python too. That's not in every language. All right, what's this one? Detect a number range. So we're supposed to write an expression that says eligible when it's this inclusive. Well, that's just in Python. Forget about Python. We're not doing Python. Oh, let me press start. Oh, did I already press start? Can I delete this? Okay. User age is between 18 and 25. So I guess I got to do it this way. It's got to be greater than or equal to 18. And its user age has got to be less than or equal to 25. And that's it. That should work. Let's see. So what's 3.6? Detecting ranges with gaps. Sure, of course. If you are less than 12, if you are less than or equal to 12, or then you do something. If it's greater than or equal to 65, you do something. Otherwise, you do 14. Now, you could structure this like, if the age is less than or equal to 12, you do something. Next, if the age is less than or equal to 65, you do something else. And where the else, see, if we were to do it the other ways, the else would be the greater than or equal to 65 case. But in this particular way of structuring the logic, you're throwing out the endpoints, the ends first, and then leaving it in the middle is the else. So it doesn't matter. And you knew that already from Python. So let's real quick do this one. Oh, gee, it's 2. Is 2 less than 7 and greater than 3? 2 is not less than 7, but 2 is less than 7, but it's not greater than 3. So this is going to type a B, I think. Yes. So what's next? Detecting multiple features from branches. All right, sure, you can do this too. And you notice these are independent if statements. They're independent if statements. That's the trick here. You gotta have independent if statements if you can have more than one output where just, you know, anyway. All right, and you know this already from Python, but let's do one of these. All right, this is the code. initializing an integer, setting it equal to 4. If it's less than 3, we do something. If it's less than 7, oh, we do, it is less than 7. F. Oh, and then we print it now, I guess. Sure. Okay, well, you can do the next one. Oh, there's more. Okay, here's one. Another challenge. Write multiple if statements. Okay, we got to write multiple if statements. We have to write, press start. Okay, we have to write an if statement for every one of these, don't we? Copy. So I'm going to put them right here. Paste. Okay. Let me change each capital I to lowercase I. And I'm going to do if car year is less than 1968, if car year is greater, if car year is greater than 1969, if car year is greater than 1992, and if car year is greater than 2001, if it, oh, we could have parentheses. You know, I haven't tried, I probably try it, might not really need parentheses. All right, so I want to replace this with, I don't need to put the curly braces if it's only one statement. So I can just do, oh, I got to do system this. Copy. Oh, and I want to print this and stay. And of course, we don't need it. Made it a comment. All right, so that's fine. I know this doesn't matter for anything, but I'll indent here just so it looks good, so it looks Python-y. And then I need to replace comma print with this. Oh no, I gotta include the, there we go. I'm gonna replace this with, and this, and this. I guess I gotta close the print lines. Close, semicolon. Close semicolon. And close semicolon. Well, let's see what this does. Wait a second, is that? I don't think this is right. I think that came later than 2001. All right, anyway, so that's challenge activity. Is there another one here? Okay, that's it. Common branching errors. There's a challenge there. Wow, they're sure. All right, missing braces. When a branch statement has a single statement, the braces are optional. But good practice always to use the braces. Yeah, well, whatever. Always using braces, even when a branch only has one statement, prevents the common error of mistakenly thinking a statement is part of a branch. Okay. Oh, look, gee, I'm confused. I'm not writing Java, I'm writing Python. I'm confused. I think the indent is what indicates that these two are in the same block, but not, it doesn't, okay? This is Java, so really, if you want this, you got to enclose that in braces. Wait. Does this work? I thought if you had an else, you always needed braces. That's what I thought. I thought if you had, okay, let's see. Let's do real quick here. Yeah. Yeah. Right. Yeah, so it executes this, and it executes sales bonus equals 20. Okay. Okay, so it did take the, okay, so the way this works is, this is the sales bonus equals 0 is always going to be the then, and title bonus equals title bonus plus 1 is always going to be the else. Sales bonus is executed either way. I see. So indentation is irrelevant. Always using braces avoids the common error. Sales bonus equals 20 is executed anyway. So yeah, so make sure you do your curly braces. Indentation is nice, but it's the curly braces that count. All right, retype the code to fix any errors. Well, I don't know, but I bet you it's just copy. I bet you it is supposed to be this and this. Does that work? Oh, I should indent that too. All right, it worked. Now, of course, really they want you to have this be indented also to there. Really, it's better if this is like over here so you can kind of see where it ends. Oh, and really we should be, so we don't get confused. All right, we can do that. And they would really like that better, but their auto grading does not parse the code you entered in that way. All right, so anyway, what's next? Oh, here's one. Input, okay, we're supposed to fix this. I think we're just supposed to say this. It's a double equal sign. Is that all we got to do? I don't know. I think so. All right. Okay. Example 2019. There's no challenge exercise in here, but you can look at it. It's just a typical problem that we've been doing. Total amount for when it is. Assume they don't have any overlapping. Doesn't look like they do. That's that. Okay. Yeah. Okay. And this is probably code to do that. And so this does a test your understanding. Here's another one. Here's another one. Tolls. What are tolls? All right. So order of evaluation. Oh God, what are we? Oh, that's what we have. Okay, of course, this is important. You got to know this. You got parentheses matter, operator precedence. You know, parentheses is the most important. Do it with the not operator, which which precedes a variable or a scalar, a literal, a true false literal. The exclamation point can precede a Boolean variable, just like a plus sign or a minus sign can precede an integer value or a number. You know, minus 5.2 is the minus sign goes first. That's got priority over any other multiplication, division, modulo. So you know the order of precedence for multiplication, division, and modulo is higher priority than plus and minus. If they're in the same expression without any parentheses, it's left to right. These are the relational operators, and they have less priority. So that means if there's something like this and something like this, the evaluation is going to be a true or false, because first it does the where's the vertical bars? They're way down here. Okay. Yeah, I wasn't thinking. Okay. Here. This is going to be evaluated first, because that's going to evaluate to some number, and it's going to be compared with this number. See, it doesn't matter which side it was be on. These arithmetic operators have precedence over any of these relational operators, which is going to end up being a true or false. This says that the relational operators, greater than or less than, have higher priority over anding and oring. Anding and oring is down here at the bottom. This tests equality or inequality, and then the logical and has priority over logical or. Anyway, so you know all that already. There's other kinds of if statements. Then there's something like this in Python. Can't remember what it is. Case statement, switch statement. This means we're going to take the value A. We're looking at the value A, and you have these cases down below. When A is 0, it's this. When A is 1, it'll do this. When A is 2, actually the way it works is, if A is 0, it's going to do all this. If A is 1, it's going to start here and do all this. If A is 2, it's going to start here and do all this. But what makes it stop is these break statements. Okay, so that makes it break out of after this point. If we didn't have these break statements, then it would be like what I said. So anyway, make sure that's the same as in Python. Make sure you understand that. This is a way to do it. If you're not going to use a switch statement. Yeah. So in other words, you don't really need the switch statement, but you can use this. You can do more things with a switch statement, because you have this because it's the break statement that isolates each case, and you'll almost always use it isolating each case, but sometimes you don't. Sometimes you don't have. Sometimes you have two cases like this, and you don't have a break in between. All right, so here's a case, whatever. Execute this. Yeah, there's a challenge in here. Let's go find it. Here we go. Rock, paper, scissors. Write a switch statement that checks next choice. Next choice is what's read in. So we're supposed to use a switch statement, huh? Okay. All right, so I'm going to do switch next choice. I guess I do a I do a beginning curly and then an ending curly, right? That's how I do it. That's the syntax of a switch. Yes, it is. And there's cases inside. Okay. I'm just gonna grab a couple of these cases. I tell you what, I'm gonna grab these cases. Copy. And I'm gonna put those inside. Okay, so we've got some cases, and I want the case to be, this is indented case 0, and it's an integer, so I don't put quotes. Case integer of 0, I'm going to print end with a new line. So it's system, I gotta memorize this. System out print. System out print. System out print line. What am I printing? I'm printing raw. And then I got to break out of this dude. Break. Oh. And then the next one is, oh, I guess we'd like to indent these. Why? No reason. All right, case 1 is case 1. And is this. Otherwise, oh, we have to do print the unknown thing. Okay, so that's case 1. Scissors. Rock, paper, scissors, 1. 2. Too fancy. 2. Rock, paper, scissors. And that's it, right? Oh, otherwise it prints this unknown. And I guess we should make this look nice. And make this good. I don't think we need this last break, do we? I don't see why we would. So I'm going to take it out. So what does this do? Very good. Okay, what is this one? Switch safe statement to convert letters to Greek letter. Convert letters to Greek letters. So it does something like use fall through as appropriate. You know, it's not going to test that. So I'm just going to copy this. Copy. Paste. This one. All right. Oh, I got to do some sort of case lower or something. I'm going to do this. How do you do lowercase in Java? you do two lowercase. I'm going to do it right here. Two, oh, no, I can't do it. Well, can I do it here? Oh, I can do it here. Two lowercase. And then I'm going to go, A, B, and any other characters on the alpha, beta, whatever. Let's see what this does. I forgot to close the switch. Doesn't like that. Well, let me just, gee, it doesn't let me do it there. And so there must be some other way to make a character case. Java character lowercase. Really? Let's see what this one says. That would be in switch statements. I'm sure if I looked up higher, it's probably there. Okay, what does it say? Oh, all right. It wants me to do it this way. Oh, can I do it this way? It's different than what. Okay, I'm gonna see. Let's see if this works. Oh no, I didn't. Oops, gotta stop it. I gotta get rid of this. Look at this again. Oh, it didn't. Oh, all right. Let's see. No, it doesn't like that. So I got to do this. So this is this, and this is this. And this is this, and this is this. Now let's see if it works. Yeah. All right. Okay, what's next? Here we're on 12, Boolean data type. Wow, there sure are a lot of these challenges. Okay, this one, okay, so you know about Booleans. In Java, it's capital. You have to capitalize the first letter of true and false. In Java, you don't. And okay, here's, I'll do the second one, and you can do the first one. Write an if else statement to describe an object. Print balloon if the balloon is balloon is true, and is red is false. Print red balloon if is balloon is true and is true, but print not a balloon otherwise. All right. If is balloon and is red, then print balloon. Okay. Print red balloon if his balloon is red. Oh, this is false. And the next one is if they're both true, then I print red balloon. And that's okay. Those two are mutually exclusive. That'll be fine. And print not a balloon otherwise. If not a balloon, not is balloon. I'm spelling balloon wrong here. Then print not a balloon. Now, the reason this will work, oops, we don't make it uppercase, we make it lowercase. Okay, now the reason this works is because each of these is mutually exclusive. It's either going to be, in the case where is balloon is false, no, it's true. In the case where is balloon is true, then it's either going to be red or not red. If it's neither of these two, is balloon is false, excludes either of these two, and then we'll just print that out. So I'm going to see if this works. And of course, there's other ways that you can do this. You can do parentheses, if is not red, then do this. So should leave the same there. Else this else this will work. Oh, I don't need this. I'm quite sure that'll work. I think even this will even. I'm really daring now. Let's see if this works. Ooh, yeah. This works. How about if I remove, since this is just one statement in here, this is one if statement. Okay. This is part of that one if statement. So if it's just one statement, then in theory, I don't even really need these curlies, do I? It's not letting me do it anymore. All right, well, anyway, string comparisons, this is 13. Comparisons, are we gonna start getting into string equality, string relational comparisons, compare to, okay. So compare to is new for Java. There's not really, I can't remember if well, anyway, so I'm gonna leave this for the next video. I'm gonna end it here. So I've taken you in chapter 3, I've taken you all the way up to section 3.12 Boolean data type, and I will make another video for the rest of it. Okay, thanks for watching.